Welcome to the Math Record. Today I'll be covering volume from revolutions. In all our integrals thus far, we have only been calculating area. However, we could also use the integral to find volume. And there are generally three types. There's revolutions around the x-axis, there's revolutions around the y-axis, and there's revolutions around another line or a curve. Okay, so similar to how the area works. Now let's do our x-axis first, because it's the simplest. So let's say f of x is 2x plus 1, and we want to find the volume from x equals 0 to x equals 3. So 2x equals 3. So let's first draw a picture. So 2x plus 1 is right here. So let's say our x equals 3 is here. X equals 0 is right here. So when we were revolving around the x-axis, this is our x-axis. So we revolve 360 in 3D around our x-axis. So basically it makes something like this, which is kind of like a cone, but just like the tip cut off. So how do we find the volume of this? Well, let's think about what we're making. And then the hint was that I actually kind of just drew in that figure. We make this line. We revolve around 360. We get a circle. And that's just what one of the lines weapon. We have infinite amount. If we have infinite amount, we make infinite amount of circles like that. And then we could put them all together to make that solid. And that's how you could get something from 2D to 3D. You just put a bunch of these slices together. So what we could do is think about how to put them, think about what this integral will look like. Well, it's just a bunch of circles, so we're taking the integral from 0 to 3 of a circle, which is pi radius squared, and then in respect to r, because that's our variable. Now we can factor out our pi, and 0 to 3, r squared dr. So what is our radius? Well, going back to how we made that, our radius was this. So what is this? Well, that is our height, and our height is calculated by our y, and our y is 2x plus 1. So we could just substitute radius is equal to 2x plus 1 in there. So pi, 0, and that will be 2x plus 1. And now we're writing r in respect to x. So dx. So when we're taking the integral of this, I forgot to square it, this is r squared. We take the integral of this, we need to distribute out r squared first. So that's 4x squared. 2x times 2 is 4x. 1 squared is 1. Take the integral. So that is x to the power 3. The derivative of this is 3x squared. We want 4x squared, so we scale by 4/3. The integral is x squared. The derivative of this is 2x. We want 4x, so scale by 2. Integral of a constant is always linear, so that's x. And 3, 0. And remember these is multiplied by pi. Now 0, go to any of these three terms, make 0, so it doesn't matter. So just plug in 3. So 3 squared is 27. 27 divided by 3 is 9. 9 times 4 is 36. So we have our pi, we have 36. Now when we plug in 3 in here, that's 3 squared times 2, which is 18, and plus 3. So overall, we have 18 plus 3, which is 21. 21 plus 36 is 57. So our answer is 57 pi. And that's the volume of this curve revolved around the x-axis. Now let's try the y-axis. So this is the same thing, but now revolved around the y. So let's say y is equal to x minus 1 squared plus 2, and we want to find the volume from x equals 1 to x is equal to, let's say, 3. Now, as we know, let's draw a picture. Makes everything easier. We start from a vertex of 1, comma 2, and we start from 1, and we go up to 3, and it follows the line of a parabola, because it's squared. So, looks something like this. And let's say this is 1, and say this is 3. Okay, now when we're revolving around the line, around the y, we have horizontal lines this time, while the x-axis, we're revolving around the x had vertical lines. So with horizontal lines, we're dealing with the x component. That means we need to write this equation in terms of x. So y minus 2 equals x minus 1 squared. Square root y minus 2 equals x minus 1. That means x equals square root y minus 2 plus 1. Okay, now that we're working with the y, we can't use these values anymore. So we need to think from here to here. So what are those values? We'll just plug it in. Plug in x equals 1. That's 0. 0 squared plus 2 is 2. Plug in 3. 2 squared plus 2. That's 4 plus 2 is 6. So we're going from 2 to 6. Okay, so we need to find this area. We need to find that volume, revolve 360 around. So when we draw a circle, this is our radius. So our radius is calculated by our x value, and our x value is this. So we can rewrite our equation, integral from 2 to 6, pi radius squared dr is 2 to 6 from pi, which we can move outside. Radius is square root y minus 2 plus 1 squared, and now with respect to dy. So distributing this out, we have our pi, 6, 2 to 6, square root squared, so that's y minus 2, square root y minus 2 times 2, and then 1 squared is plus 1. So minus 2 plus 1 is minus 1 dy. Integrating this, we get y squared. The derivative of this is 2y. We want a regular y, so just scale by 1/2. The integral of a constant is linear, so minus y. And this is the same thing as 2y minus 2 to the power 1/2. So that means this is y minus 2 to the power 3 over 2. The derivative of this is 3 over 2, y minus 2 to the power 1/2. The derivative of y minus 2 is 1 plus 0, so multiplied by 1 does nothing. So 3 over 2 to 2, we need to scale by 4 over 3. So let's delete that. 4 over 3. And we need to multiply by the pi and evaluate it from 2 to 6. Plug in 6 into there. 6 squared, which is 36, divided by 2 is 18, minus that 6, plus 6 minus 2 is 4, that's 2 squared, 2 squared to the power 3 over 2, that's just 2 to the power 3, which is 8, 8 times 4 thirds is 32 over 3, minus pi, plug in 2, 2 squared divided by 2 is 2, minus a 2, and plug in 2, 2 minus 2 is 0, 0 to any power 0, 0 times any number is 0. So this cancels each other out, 2 minus 2 is 0, plus 0 is 0. Now 18 minus 6 is 12. 12 times 3 is 36, so that's 36 over 3, plus 32 over 3 is 68 over 3. And we scale by our pi. And that is the volume of a curve revolved around the y. Okay, now let's do it around a line or another curve. So let's say we have f of x is equal to x cubed, and we have g of x equals square root x, or you could write that as the power 1/2. So we want to find the volume of this around the x-axis and around the y-axis. So let's first draw a picture of this. So our cubed looks something like this, or square root looks something like this. So it's only in the first quadrant, so let's zoom in on that. So x cubed and square root x. Okay, now if we want to do it around the x-axis, let's choose a point, let's say right here. And that means going straight down. We have this point right here. And we draw a line. So basically, when we revolve around the x-axis, this point goes a circle like this, and this point gets a circle like this. And the thing in between, this line, comes out as everything in between. So basically, from this picture, you just need to get you just need to find the integral of the circle out of the bigger circle minus the integral of the smaller circle. And the smaller one is just the bottom one, while the bigger one is the top one. So we can rewrite this as pi minus radius of the top one squared minus pi radius of the bottom one squared in respect to r. So take out your pi, radius of the top one. Well, the top one is your square root x to the power 1/2. So that's our radius also, as drawn here. So 1/2 to the power 2 is x minus, now the bottom one is this, which is x squared. X squared to the power of 2 is x to the power 6. And now in respect to x. Okay, now integrating this, this is x to the power of 2. The derivative of this is 2x, so we need to scale by 1/2. This is x to the power 7. The derivative of this is 7x6. We need to scale by 1/7. And remember, we need to multiply by pi. Evaluate it from here to here. So now let's find our intersection. So set them equal to each other. And square both sides, so that is equal to 6, that's equal to x. Subtract them. So that means x to the power 5 minus 1 equals 0. So the intersection is x equals 0 and x equals 1. Equals 1. Okay, let's delete that. So then when we do our y, we have room, 0, and 1. So when you find our y coordinate, plug in 0 to any of these two, that comes out as 0. Plug in 1 to any one of them, that's 1. So the intersection is 0, 0, 1, 1. So our x is from 0 to 1, 0 to 1, 0 to 1, 0 to 1. Okay, now we plug in 0 to any or one of these two terms, it's going to come as 0, so don't worry about it. We plug in 1 here, that's 1/2 minus 1/7 multiplied by pi. So that's 7 over 14, 2 over 14, so that's 5 over 14 times your pi. And that is the volume of this revolved around your x-axis. Now what about the y-axis? Well, if we think about it, we're going a line this way. We have these 2 points from both of them with a straight line. So when we make that circle and the one in between, basically we had to have the radius of the big one minus the small one. The big one is made by the right one, while the small one is made by the left one. So that means our equation is the integral of, from our y values 0 to 1, pi radius, and it's the right one squared, minus pi radius, the left one squared. Okay, so remember we're dealing with y now, with respect to the y-axis. So we gotta write these in terms of y. So set them equal to the y. So taking the cube root of this, which just equals to y to the power 1/3, would make it in terms of y. Now do the same thing for this. So we just need to square it. So that means x equals y squared. So, okay. So our right version is this equation, which is x to the power 3. So x to the power 3 turns into y to the power 1/2. So write that. Factor out your your pi. So that'd be y to the power 1/3 to the power 2, which is 2/3, minus your radius on the left, which is this curve, which is 1/2. Our 1/2 turns into y over 2, or y to the power 2. So y to the power 2 squared is y to the power 4th. And now it's in respect to y. Integrating this at 1, that's 5 over 3. The derivative is 5/3, y to the power 2/3. So that means we need to scale this by 3 over 5. Minus y to the power 5, derivative is 5y/4. We need to scale by 1/5, 1 over 5. Multiply this by pi. Evaluate it from 0 to 1. 0 on both of these would make nothing, so don't worry about it. Plug in 1. That's pi 3 over 5 minus 1 over 5, which is 2 over 5. So 2 over 5 pi. And that is the area of between revolved around the y-axis. And as you see, these values are not the same. They could be, but they most likely aren't. Well, thanks for watching, and in the next video, I'll cover volume from cross sections.